Assalamualaikum. My name is Muhammad Ansar Kimi bin Baharudin from section 11. I want to give an explanation about the concept of Green's theorem. Green's theorem is a special theorem exists to calculate a closed curve loop that forms an enclosed region. The curve is moving counterclockwise and always has the inside of the region on the left side of what we traverse. So here is an example of Green's theorem. This is the curve that is in a loop and make this region, which will be calculated using Green's theorem. The region and the curve is always in positive orientation, which is the counterclockwise orientation. If the direction of the arrow is in negative orientation, we must add negative at the equation. So the Green theorem is made to simplify harder line integral and to make it more convenient to calculate closed curve. So here is an equation of the Green's theorem. A line integral c f xy dx plus g xy dy equal to double integral r differentiation of g respect to x minus differentiation of x differentiation of f in the respect of y dA, which is the area. So I hope my explanation can help others to understand more about the Green's theorem concept. Thank you.
Assalamualaikum, my name is Ahmad Muhammad Fidaus. For this assignment, I found a question which is to evaluate integral y cube dx minus x cube dy, where c is the positively oriented circle of radius 2 centered at the origin. Okay, for this question, I have found three data which is to be used to solve this question, which is x square plus y square equal to r square, and I also have separated the whole equation into two parts, which is p equal to y cube and q equal to negative x cube. For using Green's theorem, I have differentiated both p and q, which is for p equal to 3y square and for q equal to negative 3x square. Then I substitute both data into our new equation, which is double integral for negative 3x square minus 3y square dA. Then I separated negative 3, so it becomes x square plus y square, which it becomes r square, which is it for polar coordinates. Then I substitute r dr d theta, which is it also for polar coordinates. Then for double integral value, which is 0 to 2 pi, which is it is a circle, so it becomes 2 pi. For other integral data, which is 0 to 2, which is the radius of the circle, which is 2. Then we do the integration and we got the answer, which is negative 24 pi.
My name is Muhammad Ahmed Iqbal. So, for our first question is use Green's theorem to evaluate the line integral for y square dx plus x square dy, where c is the triangle bounded by x equal to 0 x plus y equal to 1 and y equal to 0. Firstly, we will sketch the region based on the data given, that is x equal to 0, x plus y equal to 1 and y equal to 0. So we get this kind of region. This is x equal to 0, this is x plus y equal to 1, and this is y equal to 0. So we get this kind of right angle triangle region. So this is our main equation given from the question. Secondly, we apply Green's theorem. This is the equation for Green's theorem. So we get these two value, which is f equal to y square, g equal to x square. Then we differentiate these two equations, which is firstly we get 2y and 2x. Then we substitute into our main equation. For dy, we get limit from 0 to 1 minus x. Then from dx, we get limit from 0 to 1. Then we integrate our dy limit into the equation. Then we simplified it into our simplest form, which is 4x minus 3x squared minus 1 dx. Next, we differentiate dx into our equation, which is the final answer is 2.
Assalamualaikum. My name is Muhammad Ali Zuhair bin Abdul Muttalib. For the final question, the question is, by using Green's theorem, compute line integral y square dx plus 3xy dy, where C is the counterclockwise boundary of upper half unit this D, and x square plus y square is equal to 1. For this question, we can compute the line integral directly, but using Green's theorem, it will be more easier. First of all, we need to sketch the region like this. This is the formula used for Green's theorem. Double integral del g over del x minus del f over del y. Then differentiate g equal to 3xy respect to x, and the answer is 3y. For f, differentiate respect to y and get 2y. The limit for x is from negative 1 to 1, and the limit for y is 0 to square root y minus x squared. This is the Green's theorem formula. Double integral del g over x minus del f over del y dA. Insert the limit for del x and del y. For first integration respect to y, and the answer is 1 over 2 y square. And then insert the limit square root 1 minus x square. Next, do the second integration respect to x, and the final answer is 2 over 3.